Students take an average of 45 minutes and a standard deviation of 8 minutes to complete a statistics test. The student is selected at random. What is the probability the student takes less than 40 minutes? So what's our mu, our mean? 45. Standard deviation, 8. So the 40 is our x, that's our data value. We need to change that into a z-score, so we'll use this formula. Data value minus mean over standard deviation. We'll round that to negative 0.63 to use on our table. This is the z-score that goes with 40 minutes. So that's right about here, negative 0.63. I want the probability that I'm less than that. So the probability that the z-score is less than negative 0.63. Our table gives us probability to the left of, probability less than. So all we have to do is look up this number in our z-score table and find the probability that goes with it. Negative 0.63 on the outside, and you go to the inside and you find 0.2643. About 26% is the probability that the student will take the test in less than 40 minutes. Number 2 has the same mean and standard deviation. We want to know what is the probability that the student takes the test, takes between 40 and 45 minutes to complete the test. So these right here are our two data values, our two x's. And we need z-scores so that we can look at them on our picture and then on our table. So we're going to turn those data values into z-scores. By using that formula. And we've already done this one. And this one is 0. So we've got z-score of 0 and a z-score of negative 0.63. So we want to know the probability that we are in the middle of those, between negative 0.63 and 0. So you go to your table. These are your z-scores. Your table will show you the probability that you're to the left of those. So you find both the probabilities and subtract them. Here are the probabilities from the inner portion of the table. Probability will be less than negative 0.63. Probability will be less than 0.5. So since we're between them, we subtract them. So these again are probabilities. Same situation. This time we want to know the probability that will take more than 40 minutes. We've already done a lot of the work for this. Our data value is 40. We know from our formula that we've used in numbers 1 and 2 that the z-score that goes with this is negative 0.63. So I want to know that the probability that the z-score is greater than negative 0.63. Well, I already know that the probability that it's less than 0.63 is 0.2643. And I know that the whole area under the curve is 1. So I just take 1 minus 0.2643, and that will give me this area of 0.7357. That's the probability that the z-score is above negative 0.63. or the probability that the student takes more than 40 minutes. Number 4, I've done a lot of the work ahead of time because it's very similar to the first 3 problems. 56 is my data value. I want to plug it into this formula to find the z-score. 1.38 is the z-score that goes with 56 minutes. I want the probability that the z-score is less than 1.38. So 1.38. I want the probability that the z-score is less than that, to the left of. That's what my table figures. So I just go right to my table and I figure out that probability. That's the probability that the student takes less than 56 minutes to complete the test. What is the probability the student takes more than 56 minutes? I can use my work from the previous problem. I know from the previous problem by plugging it into the formula that when my data value is 56, my z-score is 1.38. So I want the probability that the z-score is more than 1.38. From last problem, I already know that the probability that I was less than 1.38 was 0.9162. 91% chance, 92% chance I'm in this area. So to find the other side, I know that these two things add up to be 1. So I just take 1 minus 0.9162, and I get my answer, 0.0838. Number 6, between 45 and 56 minutes. So my first step, I have to change the data values into z-scores. You can do this again using the formula. But we've already done both of these. We've already figured out that the z-score that goes with 45 is 0, and the z-score that goes with 56 is 1.38. So I'm looking for the probability that I'm in this region. So I go to my chart and I look up what's the probability that you're to the left of 0. I should say 0.5. And what's the probability you're to the left of 1.38? 0.9162. So I subtract them. That's the probability that you're in that region. Again, same mean, same standard deviation. These are figures we've done before, so I just wrote them down. You can do them again if you want. Our first step is to take the data value of 40, plug it into this equation to find the z-score that goes with it, and then you go to your chart and find the probability that the area is to the left of that z-score. So that'd be negative 0.63. 26% is this area to the left of it. Same thing, your data value here is 56. You use your formula to figure out the z-score that goes with it, 1.38. And the probability that you're to the left of that z-score is 0.9162, so that's to the left of it. We want between it, so we will end up taking 0.9162 and subtracting 0.2643. Your answer will be 0.6519. Number 8, we want to know between 56 and 60 minutes. We've figured some of these z-scores before, so feel free to use your earlier numbers. First one, we're going to take our x value, our data value of 56, and turn it into a z-score using this formula. And we get this z-score. And then we use our table, the z-score on the outside, look up the probability on the inside, and you find that the probability that you're to the left of 1.38, that's wrong. The left of 1.38 should be 0.9162. And then same thing down here, you're going to do the same thing for the data value of 60. You plug it into your formula to find that that corresponds to a z-score of 1.88. That's about here. And so you want the probability that you're in between those two. So you take 9699, subtract 9162, you get 0.0537. And that makes sense. Look at that, it's a really small little area in our picture, and we're saying there's about 5% chance you're in that area. A new car that runs on electricity and gasoline is advertised at getting, on average, 65 miles per hour with a standard deviation of 6.9. So that means that when you get a car, it's going to get about 65 miles per gallon, but some cars maybe were made a little bit better and they're going to get a little bit more, or maybe a little bit less, or maybe it depends on where you drive them. Anyway, they're spread out is measured by 6.9. That's the standard deviation. So that tells you how spread out those cars will be around that average of 65 miles an hour. So we want to know, what's the probability that you'll get more than 75 miles per gallon? Probably pretty low, right? Your average is 65. If you're going to average more than 75 miles per gallon, that's pretty unlikely. So first thing, 75, that's our data value, that's our x. We want to use our z-score formula to turn that into a z-score. That's our z-score. Next, you draw that in on your graph. We want to know what's the probability it's going to get more than that. So we look up the probability that goes with 1.45. But that probability, remember, is to the left of our z-score. So we have to use some subtraction. Take 1 minus 0.9265 to figure out that the area that we're looking for is 0.0735. About a 7% chance that you're going to get more than 75 miles an hour on average. What's the probability you'll get less than 75? We already figured that out. Less than 75 was that. These two numbers should add up to be 1, because the area under our curve, the probability that you're going to be under that curve is 100% 1. So the probability that you're more than and less than should add up to 1. These are getting repetitive, so I did some of the work for you. The first one, I'm taking the x value of 65, putting it through the formula to find that that matches up with a z-score of 0. That makes sense because it's the same as the average. And then I looked up in my chart to find that the probability that you're to the left of that z-score is 0.5. Then for the x value of 75, I put it through my formula to find that the z-score is 1.45, and then I looked in my chart to find that the probability that you're to the left of that is 0.9265. So between 0 and 1.45, that's the area I'm looking for. So I subtract my two probabilities, and I find that the probability that you're in the shaded region is 0.4265. 42% chance about that you're in that area. More than 50 miles an hour, miles per gallon. 50 miles per gallon is my data value. I use my formula to change that into the z-score. I use my table to find the probability that you're to the left of that. So to the left of the z-score of negative 2.17, that probability is 0.0150. But look, I wanted more than. I wanted this area. So I'm going to take 1 minus that to get my answer of 0.9850. I did not show video for 13 through 16 since they're very, very similar to the ones that we've already worked. In fact, most of the busy work you already had done. A company advertises that its light bulbs last an average of 500 days, so the average, the mean is 500 days, and a standard deviation of 100. If you purchase a light bulb, what's the probability that it will last for more than a year, for more than 365 days? Well, what do you think? Is it going to be pretty good? Not a good probability? Well, on average, they last 500 days. So you'd think that, boy, it's probably a pretty good % chance that they'll last over 365 days. Let's see. Our data value is 365 days. And again, we want to use this same formula to change to a z-score. (365 days) goes with a z-score of negative 1.35, about here. We want to know what is the probability that you'll last more than a year. Well, our table, when we look up negative 1.35, we're going to find that the probability that you're to the left of the z-score is 0.0855. No, 0.885. So then that is this probability. So then we want to figure out what's the probability that you are to the left. So we do 1 minus 0.0885. .9115, about a 91% chance that your light bulb lasts more than 365 days. Pizza restaurant delivers pizzas in an average of 18 minutes. So our mean is 18 with a standard deviation. So standard deviation, or sigma, is 2.3. They want to guarantee delivery in a certain time. They don't want to give away a lot of free pizzas. They only want to give away free pizzas more than 5% of the time. So we're looking at finding, okay, we want the top 5%. Where's that going to be? I'm not exactly sure where it is, but let's just say right there is 5% of the area. So we want to find the z-score that matches up with 5%. But now actually, our tables give us to the left of that z-score. So if this is 0.05, 5%, then what's the probability that you're to the left of this phantom z-score that we don't know yet? Well, that would be 0.95, or 0.9500. So here's what you do. You go to your table, and you look in the middle numbers, in the probabilities, and you search until you find a number that's as close as you can get to 0.9500. I found it. Let's see. I'm going to have to pick one here. I'll pick 0.9505. That's about as close as I get. What's the z-score that goes with that? Well, it's 1.65. So this time you're kind of doing this backwards. You're starting with the probability, going to the z-score, and now we'll have to change that z-score back into a data value. So if you have the z and need the data value, use this formula. That'll take your z-score, 1.65, times your standard deviation plus your mean. $21.795, or we'll just round that to 22 minutes. So if they promise that they're going to deliver in less than 22 minutes, given this average time with this standard deviation, they should only have to give away free pizzas about 5% of the time. Teacher gives a test with an average score. So our mu is 72 and standard deviation is 6.1. So that means a z-score of 0, that's going to be where your 72 is. And then as you go a standard deviation out, that'll be 6.1 higher. Okay, so if the lower 10% of the class is to receive Fs, what's the cutoff score for an F? Okay, so we're starting with a probability, 10%, 0.1. I don't know exactly how much of this will be 10%, so I'm going to guess. Maybe in here somewhere. Yeah, it might be a little further. That this is the lowest 10%, or 0.1000. What I need to know is what z-score matches up with that area. So I go to my table, my chart shows to the left of the z-score, so I can just look in the middle numbers. Now I want to look in the probabilities for 0.1000. That takes me a while sometimes, but I found it, and it seems to correspond with a z-score of negative 1.28. So now that I know that, well, okay, I know the z-score, but now I need to know what's the data value that corresponds with that. So I have the z-score, I need my data. So I use this formula. $64-ish. So if the cutoff score for the bottom 10%, we first found the z-score and then we turned it into a data value, that's a 64. And that makes sense, right? If the average was 72, 64, a little below that, that's your cutoff score for an F. Average price, 6,500. Standard deviation, 850. We want the middle 75%. I'm just guessing where this is. If I have the middle 75%, so this area will be 75%, 0.7500. That means I've got 25% split up between these two tails. So to figure out how much is in each tail, I take 25% or 0.25 divided by 2. 0.1250. That's going to be the area in each of the tails. If I add up 0.1250 plus 0.75 plus 0.1250, I'll get 100% of the area. I need to figure out what is the z-score that goes with that area of 0.125 to the left of it. So I go to my table. I look in the inside, in the probabilities, for the probability of 0.1250. I get pretty close. I found 0.1251, and that goes with a z-score of negative 1.15. So by reason then, this one, since this is symmetric, this z-score will be positive 1.15. So I use my formula now. Now that I know the z-score, now I can turn that into data values. What prices go with those z-scores? So I have the z-score. I need the data value, so I'm going to use this formula. And I plug in. I'll do the same thing for the other z-score, 1.15. So the price range, their low price is 5522.50 and their high price range is 7477.50. That'll give them the middle 75% of the values.